Okay, so we're going to take a look at a couple of different commands here. We're going to look at the servo and putting your code into an infinite loop. Okay. Okay, so the very first thing we're going to do is new file. If you're in class, just wait until we're finished and then do it on your own. Okay, so we have our servo plugged into port 2 for motors. Okay, so the servo has a 3-wire, three pins on it. We're going to plug that into port 2. Okay, and then we're going to have our limit switch. That's going to be on digital 1. Okay, so the very first thing we're going to do, as usual, is set up our motors and sensor setup. So under motors, we're going to go ahead and call it left servo. Notice I'm just calling everything left automatically. Okay, and we're going to call it a 3-wire servo. That's the type. Okay, and then under digital sensors, we're going to have left switch. Okay, notice I'm just saying left switch just as an example because you're supposed to. All your names for these should have no spaces, no special characters, only combinations of upper and lower letters, and they should be written in camel case, which means lowercase first word, every subsequent word is uppercase. Okay, we click OK, it generates our pragma statements. Okay, the thing I forgot to do, of course, was to go save as, and we want to save this stuff right off the bat with a name that helps us to remember what it is. Okay, so I'm going to call mine. I have kind of a long name at the end here. Basically, what I'm going to call this is I'm going to call this infinite loop servo. Okay, and click save. Okay, now the idea here with an infinite loop is that a lot of times with systems that are mechanical is that we want it to function all the time without human interference. If you had to go out, for example, if you had an automatic garage door and you had to basically every morning go out and hit a start button so your automatic garage door would function, it would defeat the purpose of having an automatic garage door, right? If you had a Wi-Fi video enabled doorbell, if you had to every morning click start on that Wi-Fi video enabled doorbell, it would defeat the purpose, right? So mechanical systems and systems that are meant to be automatic or automated and unattended often don't have a start button. Basically, you plug them in and they start to run their program, and the program itself is set up to automatically configure, automatically get it to a point where it can start and then run as a person would expect it, right? So this is so basically how this is achieved is by putting all the code into one big infinite loop. All right. Okay, and we're going to talk a little bit about what a loop is. Now, how we get to this in RobotC is we go under control structures, and we're going to open up control structures again, and then we're going to do a while loop. Okay, so while is I don't know, everyone has a favorite. My type of favorite loop is the while loop. Okay, so we're going to drag over while, and then we're going to click fix formatting. Okay. Okay, and then under conditions, so basically while all it does, so remember how we talked about in task main, we have these two curly braces on 6 and 13. That defines the code block that is task main. So all the lines of code, lines 7, 8, 9, 10, 11, 12, get played in order, get run in order while task main is running. Okay. So the purpose of a loop, in this case a while loop, is to repeat lines of code. Okay, so and how it does that is by defining another code block, right? So now we're inside, so think of it as like a folder inside a folder, right? So we have another code block, so our while loop code block is defined by this curly brace on 8 and curly brace on 10. Okay, so anything between those is included in the loop, all right? So let's go ahead and add a little bit of code here. And basically what we're going to do is we're just going to add this, we're going to add our code into the while loop, and then we're going to come back and add the condition and talk about how it's going to run. Okay, so in this case, we're going to go ahead and it's going to be very similar to what we did before, except we're going to use a setServo command. Okay, all right, So we're going to go ahead and open up natural language until, and we're going to do until bump again. Okay, so it's very, very, very similar. We have another until bump, right? Okay, and I can just tab this in if it's not right. And then on line 10 and 12, we're basically going to set the servo to a couple of different positions, if that makes sense. Okay, so a servo is not like a motor. You can buy them so they're like motors. Servos come in what's called a continuous, or I think it's non-continuous. But basically, it's whether the servo can go all the way around and act like a motor, like it can move slowly 360 degrees and just continuously move, or whether the servo just can move like up to like 270 degrees or 360. So basically, it can move back and forth. The difference in RobotC for a motor and a servo is that a motor, when you put a number in, that number controls how fast the motor moves, right? Like how fast it's spinning. With a servo, it just controls the position. So the servo will set itself to a 0 position. If you can imagine, -127 is like, if you're using like your math quadrants, right? If 0 is set to 0 degrees, then like -127 would be like if it moved up to the left past 90 over to 180, and if you moved 127, it moved down, past 270 back towards 180. Okay, so you can imagine that it moves left to right. You'll get the picture. Okay, so the best way to do this is just to experiment with the servo. Just as long as you know that when you're setting the servo, you're setting a position that is somewhere on this like 0 to 360 degrees, and you're just setting it to a position, then it stops. You don't control how fast it gets there though. So the servo will move as fast as it can move to whatever position that you set. All right. So we're going to go ahead and drag over setServo to lines 10 and line 13. Okay. So basically, this is how our program is going to go. It's going to wait until bump. Okay. We're going to click the switch. The servo is going to move to some position. It's going to wait there until we click the switch again. It's going to move to a second position. Then, because it's in a loop, it's going to go back up to line 9 and wait again. Then it's going to set it, once we click, it's going to go to line 10, set itself into a particular position. Then it's going to wait on line 11. Then it's going to, once we click it again, it's going to go to line 12, set itself to a particular position. Guess what? It's in a loop. It goes back up. Okay, now each time it goes back up, like once it gets to line 13, it hits the end of the block of code, right, that is the while loop. It goes back up. It doesn't just go to line 9 though. Okay, interestingly enough, it checks this condition. All right, so it checks the condition, and all the condition is, it's a statement that is either true or false. No matter how complicated, it's what we call a Boolean statement, which is either true or false. Okay? It's the favorite statement of all ghosts and goblins. It's a Boolean statement. Okay? So, thank you. You guys are the heroes. You guys are the heroes. Every one of you a hero. Okay? All right, thank you. Okay, yeah. So it's a Boolean statement, and the thing you have to remember about Boolean statements is that no matter how complicated, it can be a statement that has like, I mean, it can be literally an entire page long. It can be multiple lines long. But at the end of the day, it all boils down to that statement is either true or it is false. So in our case, we just want a statement that's always true. We want this loop to continue forever, okay? So we're just going to put true. So we're going to spell it correctly. Now remember that in RobotC, it is case sensitive, right? So true is not the same as true, okay? But it will correct for it. And to be honest with you, I'm not remembering right now, so we're both going to find out together when I run this whether it was true or true. All right, okay. So the idea here is that if it goes up, it's going to run, when it gets to line 7, it's going to check this condition. If the condition is true, if the statement is true, it will run lines 9, 10, 11, 12, then go back up to line 7 and check again if the condition is true. Now, in other cases, the condition might not be true. We might use that idea to either skip code or play the code in repeat, right? But in this case, we're just setting it true. It's always going to be true. So each time it's going to check at line 7. Is the condition true? Oh, it is true. So it's going to play 9, 10, 11, 12, then go back up to line 7. Oh, is the condition still true? Oh, it is true. Then it's going to go 9, 10, 11, 12. It's going to go back up to line 7. Oh, is the condition true? It is true. Then it's going to go, am I being repetitive? That's funny because you know what else is repetitive? Loops are repetitive. Okay? Thank you. All right. You guys, thank you. Thank you. Thanks, guys. Thank you. Okay, you guys are the best. All right. Okay, so let's just go ahead. So we have this, what I would call this is the skeleton of the code. So all the functionality is now in the code. I've done nothing but drag over code from the function library. I put the skeleton of the while loop, the skeleton of the commands in, all in, and now I'm going to go start making it specific to my program that I want to run, right? So the sensor port is going to be left servo. In this case, guys, we're just going to go maximum, which is 127, just to experiment. Oh, sorry, until bump. I apologize, I messed up there. Until bump is left switch. Okay, remember that this is the delay, right? Delay time in milliseconds, which we're always just going to set at 500 for now. Okay, we do until bump again, which is 500. So notice I copy and paste these so I don't have to type them again. Servo port is going to be left servo. Okay. And the position is going to be 127. Again, it's going to be left servo again. And this time the position is going to be negative 127. Okay, so you guys are going to go ahead and write this. And then please play around with the positions of the servo to kind of understand how the servo works. Okay, best of luck.